Hi everybody, Stephen here. On this episode, I'm going to talk about how to capture packets at the NSX Edge Node. This was actually requested by one of my subscribers, so sit back and enjoy. See you in a bit. Well, thanks for sticking around. So why don't we jump right into it? And as usual, I normally say at this point, if this is stuff that you're interested in, hey, please subscribe to the channel. It helps me out quite a bit. And again, for those of you that already have subscribed, really appreciate it. So this is going to be a lecture portion and then a demo. Okay, the lecture won't be that long, but there'll be a kind of review part. Not really a review, but anyways, a review part for some of you. So for those of you that want to watch the review and just rather see the demo, you can fast forward ahead. Now, just a couple of things I'd like to point out. There's different ways you can do packet captures in NSX. Some of the ways is using the live traffic analysis and the GUI. I've demoed that in my packet capturing demo. This won't work for the Edge. That's basically for VM to VM communication. Now, some other ones that you could use is the PK or packet cap-UW command. That's been around for quite a long time. Or the NSX, this is part of the NSXCLI, the NSXCLI. Is the start capture command, which I've actually demoed in the past. Now, depending on your edge node, if it's a VM running on an ESXi host, right? Well, if it's a VM, it's going to be running on an ESXi host. You could actually use this command. If you know the interfaces, you could actually capture packets of whatever interface that edge node is using. The problem with this command, it doesn't work if your edge is bare metal. So much for that. That doesn't work. What will work if it's a VM or if it's bare metal is the start capture command. So we're going to take a look at that command. Actually, I've got it right here. Okay, so it's a fairly straightforward command to use. You got start capture, the interface, and I'll show you how I can determine my interfaces when I do my live demo. Specify the interface. Then you can specify the direction, input, output, or dual. Dual would be for both in and out. Then your expression is your filter. I want to filter on, in this example, my IP protocol would be hex 01, which is ICMP, or it could be like IP for my IP address or whatever. And I'll do some of those demos as well. You could also save this to a file, and I'll demo some of that as well, right? But I could actually put a parameter here, file, and then whatever the name of the file is. And I'll do one of those and show you, okay? There's also another parameter here. I can specify count. If I don't want to get 1,000, lines coming back, I just want, show me 10 lines, that type of thing. That's a count. So we'll actually see that, okay? So before we jump right into the demo, let's do a real quick packet walk, okay? Now, I've already done some basic packet walks in the past. If you're kind of new to that, watch my first packet capturing. I'll probably leave that as a link towards the end of the video for those of you that haven't seen that. Right now, I'm just going to show you a packet walk from a VM going out to the physical world. So in NSX, I've got this virtual machine over here, and it's on the blue segment, which is web segment. Notice it's running on this ESXi host. Now this VM here wants to talk to the outside world. Here's a physical machine and my physical router. Okay, so in order for us to get to the outside world, I'm only doing a single tier environment here, so there's only a tier 0 gateway. We'll need to go from our ESXi host, our compute. We'll need to get over to an edge host. Okay, so our edge transport node, and you'll notice my edge in this example has a TEP. And then it has an uplink. I'm keeping it really basic and simple in this diagram instead of us kind of going crazy here. So let's say this VM here, the blue VM, which has an IP of IP1 and a MAC address of MAC1, wants to ping this physical machine that has an IP of desktop 1 and a MAC of desktop MAC. So how does this look? Well, if I look at the layer 3 packet, the source IP will be the blue machine's IP, IP1. The destination IP would be the physical machine's IP. Let's assume that, everybody's talked. There's no ARPing involved or anything like that, right? But anyways, so we see we've got our source IP is IP1. If I zoom in a bit. Okay, and the destination IP is desktop IP. There's my layer 3 packet. Now, what this machine has got to do now, the blue machine here says, oh, that machine's on a different subnet. It's on a completely different subnet. So it has to send it to its default gateway, which is the distributed logical router. So that's where the layer 2 stuff comes in. So the source MAC will be the MAC address of the VM, which we see right here. Source MAC is MAC 1. And then we see the destination MAC is the VMAC of that distributed router. Okay? So that's what it would look like in the payloads, whatever. So it's going to send it out to that interface. Okay? The distributed router is going to receive it, and it's going to look at its routing tables and says, oh, you want to get to this IP address, desktop IP. Well, it's on a different subnet. I don't know where that is, so I'm going to send it to my default gateway. And again, that would be up here to the SR. So if I drew a logical diagram just real fast, so everybody's on the same page. Here's the VM1. It's going through a tier 0 gateway. And here's the segment, web segment. Here's the DR component. And because we have an uplink going out to the physical router, and then my oops, I can't draw it. Won't let me draw up there. There's the desktop. I got to draw my SR, and over here. So now, when we're doing our ping, it's leaving web. And it's going to its default gateway, which is that. Sorry, this is a DR component. Let me fix that real fast. I said that's a DR component. My mistake. Distributed router. So it goes to its default gateway, which is the DR component. The DR component receives it and says, oh, you know what? There's a default route that's already created between the DR and the SR in this gateway. It's automatically done for you once you say you have an uplink. So it says, I need to send it to my SR component. So it sends it out to the edge. And the SRs live on the edges. DRs live everywhere. SR lives on the edge. Now the SR look at its routing tables and says, oh, you want to get to this network here. And the physical router and the edge formed a relationship, so they exchanged routes. Let's say it was BGP or OSPF or whatever. But anyways, the SR component's going to look at its routing table and says, oh, I need to get to that IP. I got to send it to this physical router, and then the physical router will hand it off to the other one, okay, to the physical machine. So it's kind of important from a logical perspective that you understand what's going in here. Now, at this point, if I drew, let's change my colors, and let's say I'll draw a blue line here. I'm drawing it kind of through the middle of the SR. It's kind of an easier way to explain it. Below the blue line, this is overlay networks, overlay. So it's going to be, Geneve. And above it is VLAN. Okay. So this SR, you see the SR kind of sits in the middle of the blue line. It's going to have a VTAP because it's on an overlay network. So Geneves do my in-cap and decap. Then it's going to have a connection to the VLAN as well. So that's why when you look at my picture here, I've got a TAP and I got a VLAN. Just keep it nice and simple. Okay. So again, the DR receives it and says, I need to punt it over to the SR. Where's the SR? Well, it doesn't go like this. It doesn't go kind of across like this and then down. It doesn't do that. That's just a logical representation. It needs to send it out over to across the network. So you'll see it going. Come on. Here we go. So it gets routed. Now, actually, let's look at it. Once it gets through the DR, what's changed? The layer 3 stuff's going to stay the same. The source IP is IP1. That's where it came from, the blue VM. The destination is the physical desktop IP. That hasn't changed. That doesn't change. What does change is the layer 2 stuff. We're now on a different segment. Okay. Actually, I don't really actually have this segment drawn in here, but we're actually on a different segment. The source MAC is the VMAC of the distributed router, and the destination address is the VMAC. So we're at this point, technically, we're sitting here, logically speaking. And here's, I said VMAC 3. I'll call that VMAC 3 is the SR. Okay, so we know we need to send it to our SR. There is kind of a logical connection between those, but I'm not showing that in this diagram, or else it would get really confusing. So it needs to exit this host, and what happens? Boom. So it exits the TAP now, and then here is the payload as it exited I'm not going to say that point, as it exited the DR, okay, which would actually be technically that point, okay? We see the payload's the same. We see the source and destination IP is the same, hasn't changed. The blue machine wants to talk to the physical. And then we see the layer 2 stuff has changed. It's the VMAC of the DR and the VMAC of the SR, okay? You'll see the VNI over here is 665, in this example, 6653, whatever, just randomly picked a number. What that is representing is this right here. Remember this red line I'm showing? There's actually a logical connection. If I actually did something like this, there's kind of an overlay between that. It's a logical connection, okay? And in order for us to go across that, we have to go and do encapsulation. So that's what this VNI here is, this guy right here. Then you see, if I zoom in a bit, oops, I want to zoom in. That's not letting me zoom in. Let's try this out. There we go. This is all the Geneve header in purple. So you'll see the layer 3 stuff. The source IP is the TEP 1 IP, which is this TEP here. And the destination is the TEP's IP on the edge way over here. Then in this case, since our TEPs are on the same subnet, they're not on different, not going through routers. We see the source MAC is the TEP MAC of the ESXi host, and the destination is the TEP MAC of the edge. That's going to get fired across the network. It's going to get fired across the network, arrive over at the TEP. The TEP's going to look at the Geneve information, say, no, that's me, all right. It's going to tear all that off, throw it in the garbage. It's going to keep this original payload and then send it up. There we go. So the original payload gets sent up to the SR. And that's the same payload that exited this DR component. Well, let's take a look. We see our source IP is the blue VM, destination is the physical box. That never changes. But we see the layer 2 is the source is the VMAC, the distributed router, and the destination is the VMAC 2 of the SR. Okay? Now that's going to receive it, and it's going to look inside its routing table. So the SR now has it, and it's going to look inside its routing table. By the way, I already mentioned, you notice this is all de-encapsulated now. It's no more Geneve. So it's going to look at its routing table, and whatever routes this physical router told the SR, it's going to look and say, oh, I need to send it over to this router's IP. Or sorry, I need to send it to this router's interface. So watch as it exits out to the SR. So it comes out here. What do we see? The layer 3 stuff stays the same. Source IP is IP1. That's the VMs. Destination is the physical. Never changed, right? But when we look at the layer 2, we see tier 0 uplink MAC. Sorry, let me clean this up. We see the tier 0 uplink MAC. Let me kind of show you that. Would be right here, the interface of that uplink for the SR, and the router MAC address. So right over here, because these guys are on, technically, if I scroll down now, these guys are all on the same subnet at this point. So this is a different layer 2 network. So this is why we see this change. It's going to arrive at the interface of the router. The router is going to look up in its routing tables and say, oh, yeah, I know where this machine is or whatever, and then it fires it out, and it comes out over here. So now when we look at it, again, the layer 3 stuff stays the same. It hasn't changed since it left here. Source IP is IP1, destination is the physical. It's the layer 2 stuff that's changing. We see it's now this router MAC 2 is the source, so it's coming out of this interface, and it's in this example, this desktop is on the same subnet as that interface there. So the destination is the MAC address of the desktop. Let's just assume ARPs are done and all that kind of wonderful stuff. So this is what we should expect to see as we're going. And let's, yeah. This is what we should expect to see as we're going through here, okay? So why don't we jump into the demo, and I'll walk you through it, okay? See you back in a minute. So we're back. And if you haven't subscribed to the channel already, hey, hit that subscribe button. It's free and it helps me out a lot. So let's jump right into it. Let me just get my mouse over here. Lost my mouse. Okay, so first of all, let's look at my network, my NSX topology. I'm going to go into networking. I'm going to go into topology. I have a 2-tier environment set up. So I have a tier 0 gateway and I have a tier 1 gateway. I created 3 segments. All we care about right now is the web segment. So you can see I'm zooming on the web segment. And then if I zoom in a bit more, let me move this up. If I click on this, you'll notice I have 2 VMs here, Web 1 and Web 2. If I click on Web 1, I can click on interfaces here. We see the IP address of Web 1 is 172.16.10.11. Okay? Does it show me where it's running? It shows me the MAC address as well. Hey, let's write that down, okay? So Web 1, MAC, I'll say DC69, and the IP is 172.16.10.11. Okay. That's basically about it. If I close this, as I mentioned before, it's going from a web segment, it's going up to a Tier 1 gateway. From the Tier 1 gateway, again, it's going up to the Tier 0 gateway. And this is the IP address of the uplink, this uplink of the tier. Now, I only got one. I'm just keeping my resources very minimalistic right now. You would probably see multiple interfaces because you want redundancy. I only got one path, one edge, just to keep things very minimal and very easy. I'm trying to set up for a federation demo and just trying to reserve resources. So there we go. I've got that. So now a couple of things here. Let's first of all do a ping from my web machine. So let's go over to my vSphere. You'll see web is running on where is it? Right over here. Web is running on host 3. Okay. Let's open up the console. And my physical environment is, I'm going to ping 192.168.70.1. That's actually my my Ubiquiti gateway going out to the real world, or sorry, to the internet. So, maybe I should try to log it in first, huh? Let's try that one more time, folks. Come on. So I could ping my other web, 172.16.10.12. That's east-west. I can ping my app and database. Doesn't really matter. 20.11 is my app, is on an app segment, and my 30 is a database on a database segment, all going through the Tier 1. I got east-west going on. Big deal. We're not talking about that. We're talking about the edge node. So I'm going to ping the outside world, ping 192.168.70.1. And I'm just going to let that run. Okay, so that's hitting my gateway basically to go out to the internet. So let me get out of there. Let me go back to here. Actually, do I want to? Yeah. Now I said it was running on host 3. So let's check out something on host 3. Let's go back into NSX and let's look at my edge and let's look at host 3. So let's go into system. Let's go into hosts. I've got an edge cluster where my edge is running, and here's my compute cluster where my VM's running. There's host 3. So web 1 is running on that, and what's its TAP? It's 172.20.11.153. So let's keep that in the back of mind, 11.153. If I look at my edge now, you'll see my edge node. I only got one, okay? And you'll see actually, let me go into nodes here. That's just, so let's go into nodes here. And here's my edge node. Sorry, I got distracted there for a second. There's my edge node. And you'll notice I got 3 tunnels. Okay, because it's got a tunnel to host 1, 2, and 3. Okay, that's why there's 3 tunnels. I also got 2 NSX virtual distributed switches. I'll be back to that one in a second. Actually, let me click on it. One's in a overlay zone and one's in a VLAN back zone. This is important because you got to know kind of how your interfaces are configured. There's my tap IP right there of the edge. I only got a single tap on this edge, just keeping things simple, right? If I have multi-taps, I'd have to be capturing on multiple ports. So it's 11.154 is the edge. Now let's go back to the NSX virtual distributed switch here. Your edges can be configured a whole bunch of different ways. I can configure it with one virtual switch and have multi-taps, or I can configure it with multiple virtual switches, okay, and have a single tap if I wanted to. There's a lot of different variations. If it's a physical Edge, again, you've got a lot of possibilities on configuring it. For example, a physical Edge node can have up to 16 physical cards. The VM Edge has up to 5. That's new, as I think it was 3.2.1. It used to be 4. The first one is management, ETH0. The remaining 4 is fast path, FP, fast path. Fast path 1, 2, 3, and 4. So it's kind of important that you know that and how it's configured. If I go to edit my Edge, I'll show you a couple other things too that you can look at interfaces as well. But if I look at my Edge, how I configured it, if I just minimize this, I actually have 2 virtual switches on the Edge. One is for overlay, one is for VLAN. And I just kept mine simple. So I look here, and then when I scroll down, the uplink profile, Edge single NIC uplink, and you'll notice uplink 1 is going to a port group. Okay, now these are the fast path interfaces. Notice the top one, that's my first one, that would be fast path 1, right, or the first one. And if I click on that, you'll see that's on overlay transport zone, and it's using a single NIC uplink profile. So it's just got 1 NIC, and that's it. And it's using uplink 1. Okay, so this kind of configuration is important to know on your Edge. Okay, so let's kind of now go and take a look at the command line on the Edge. I'm going to cancel this. So I'm pinging the outside world. Let's go to the Edge and see what we can see. Let me minimize all this stuff. Normally I like to use putty, you know what, instead of MT putty. Actually, you know what? There's another way for me. Yeah. Bear with me 1 second, folks. Okay, I'm back. I installed putty. I'm just like that. Anyways, so let me, I already put in my NSX Edge 01. Let me click on that. So I'm actually going to log in as root. I'm going to log in as admin on the Edge. Did I type in that password right? I think I may have messed up the password. Time for a new keyboard. Keys are sticking. Let me expand this up a bit. You probably notice I got my video up on the right corner so I don't block some of the command stuff. Let me go into here and just change a few things. Make it maybe a bit easier for you folks to see, and hey, for me as well. Okay, so I've logged in as admin right now, and I've got a ping going on. So first thing I guess I want to do is maybe type in get interfaces. Let's take a look at that. Wow, there's a lot of interfaces here, right? So if we scroll through here, you'll see there's FP0, fast path, okay? And if I scroll back, you'll see ETH0, shows me the IP. So this is the ETH0 is always your management network. There's the management, or there's the IP of this Edge node. FP0 in my environment is set up as the tap, because I showed you the first card, single NIC, boom, away we go. It's set up as the tap for the overlay, right? And if I go, and you'll see the status is up. If I go into FP1, which is VLAN back, that's my uplink, this status is up. And it shows me MAC addresses and stuff like that. And then you'll see it's active. And then if you look at FP2, it's down. I'm not using it. FP3 is down. I'm not using it in my lab environment, right? So it's important that you understand how your Edge is configured, okay? And what interfaces are configured. And like I said now, in the past best practice, and I don't know if this has changed, to be honest with you, in the past was you only had, you had 4 NICs, 1 was management, and you had 3 left over. So that didn't really give you a lot of flexibility. So I got 3 interfaces. Do I use 2 for my overlay and 1 for VLAN? Do I do 2 for VLAN and 1 for overlay? So what they came up was with the single NIC configuration redundancy. Once you had a single switch configuration, once you had 2 interfaces on that, you had VLAN back and overlay back. So you had multi-tap support. Now it's going to be kind of different because I can actually now say I want to use two NICs for overlay, Tunix for VLAN, which I kind of like better, to be honest with you, but I don't know if that's changed or not on best practices. But anyways, I digress. All right. So right now, my fast path ETH1 is my tap. Sorry, fast path ETH0 is my tap. Fast path ETH1 is my VLAN. So let's type in start capture interface. Oh, I don't know what the interface is. I can hit question mark. If I hit the question mark, it comes back, it shows me all these different UUIDs on interfaces. Okay, you'll see over here, fast path 0. So if you're not sure, you can hit question mark, and it'll show you these are the valid interfaces I see. I'm going to type in FP-ETH0, and I'll hit enter. And you notice all the stuff is just scrolling by like crazy. Okay, so great. I could do something like that. Now, if I want to be more specific, I can say, okay, I want to do a count of 5. So it's going to give me 5 lines. I hit enter, but I'm not filtering. There's 5 lines. Okay, I could do, maybe I'll save that one for later. I could do file and then file name, and it would save it. Yeah, let's do that. Let's do capture of 20 file, and then I'll call it my capture. Hit enter, and it should be counting 20. There we go, and it just saved it. Where did it save it to? Why don't we take a look at that now and get that one out of the way. So I'm gonna go back into empty putty, and I'm gonna assign in as root. So let's load up this guy. So I'm gonna go to my edge. I'm now gonna sign in as root, so I have access to the file system. And then cd space root images, VMware, always have to look at this, and then NSX, and the C file, cd space file, store. And if I do an LCL there, you'll see there's my file right there, my capture. So I signed in as root to see that. So I could use something like Wireshark to view that if I want to, right? So actually, why not? I may as well be complete and show it to you. Let me run WinSCP. I'm going to log into my Edge. And so right now I'm actually images, VMware, NSX, file store. There's my capture. I'm going to copy this across. You probably see I got one already there. Copy it. I'll say yes to replace it. So there's my file there. Let me close that down, and let me use Wireshark now. So let me just go file, open, document. So there's my file, my capture, and you can see you can actually go through and analyze some of the stuff with Wireshark. Okay. So that's one thing you can do. I would be very cautious about, especially if you're going to be like, I think there is a limit. It rotates, I think, after 20 meg, if I remember correctly. But I would be very cautious that you don't run out of space on your edge, because that would be bad. All right. So if you just want to do like what I did, let's capture 30 frames or whatever, and then take it offline. Make sure you delete it. I didn't delete mine, but I should go in there and delete it. Okay, and do it. Okay, great. So that's captured it to a file. I don't want to do that anymore. I can see count 5. Now let's type in what do I want? Count 5. How about expression? And I want to filter by IP address, and I want to filter on the tap, because there's a lot of stuff going through this edge. You got all your other transport nodes talking to the outside world. I just want to filter on maybe the tap of host 3, right? So I can type in IP 172.20.11.153. Then when I hit enter on it, you see, okay, so there's where I typed in the command. So what do we see here? A couple things. First of all, I want to point out, I see a VNI 0 here. That sounds really strange. What is that? Bidirectional forward detection version 1. we use bidirectional for detection to detect link failures, right? So these are kind of like heartbeats. So I can kind of ignore that because I'm capturing it from that interface, right? There's another one right here. What do we see? Okay, we see VNI 11400. What is VNI 11400? Let me just go to my converter here. Okay, so when I go to convert my hex to ASCII converter, 11400 is basically VNI 70656. Why do I care about that? Okay, so let's keep that in the back of our mind. VNI 70656. What do we see here? I see this is my source tap right here. Okay, that's host 3. And to the destination, which is my edge, 2011.154, port 6081, it's Geneve. Okay. I see what's encapsulated now. If I actually go into here, let's get all this. This is what's been encapsulated inside Geneve. Up here, that's all the Geneve header there. So I see the source is 0250564452. That should be a familiar number. That's the VMAC address of our gateways of our distributed router. I see 02505656. Sounds very familiar. 5300. What's this MAC address? Let's come back to that in 2 seconds. I see the source IP 172.16.10.11. That's Web 1. 172 destinations 192.168.70.1, and it's a ping, right? So this is the ping from my web going out to the real world. So we got a couple of questions here. What's this VNI, right? And what's this MAC address? Okay, I'm going to create another session going into the Edge node. Let me fire that up. Let's go into the Edge node. Let me log in as admin. And we're one bang. Recording. Yep. Let's change up some stuff here just to make it a little bit easier to see. Change settings, appearance, change up at 12, colors, background. What color do I want? Maybe I'll pick this one. That should be okay. There we go. You should be able to see that okay. So this shows me the other session here. Let me make this a little bit bigger. And I want to look at some more interfaces here. So let's take a look at this. Let's type in get logical routers. And it comes back and it shows me. Remember on the Edge node, what do we find on Edge nodes? We find the SR. So remember, I'm in a 2-tier environment. So I got a tier 0 gateway that has a DR and it has a SR because that has an uplink. Then I have a tier 1 that I'm just doing routing only, so it only has a DR. So you see that. You see the DR for my tier 1, see the DR for my tier 0, and you see the SR. Notice over here, again, VRF, virtual router and forwarding, right? Which is kind of strange. Anyways, so I'm going to type in VRF1. I'm going to hit enter. Then I'm going to type in get interfaces. I can actually do something like this, get. Is it IP route? I always forget. It's get route. And you see my routing tables. I won't go through that, but I'm going to type in get interfaces, hit enter, and I'm going to scroll up. So I'm on the SR, looking at the interfaces on the SR. I see that there's a loopback. Oh, sorry. Actually, I scrolled a bit too fast there. There we go. Okay. So I see there, the first interface I see is this one, and you see the interface IDs and all that wonderful stuff. You see it's black hole, it's a loopback. So that's a loopback interface. I'll leave that one alone. This is the one I'm interested in right here. There's the UUID of it. Again, it's called BPSR0-port. BP is backplane. This is the interface that connects the SR to the DR. That's automatically created. You'll notice this says backplane. It's a LIF. There's its IP address that's auto plugged in. Oh, look at the VNI 70656. That was that 11400 that I talked about. So that's the overlay network connecting the DR to the SR, which is auto plumbed. This is automatically plumbed for me for NSX. Notice the MAC address 02505653.0. Let's go back to this guy. And where do we see that? There we go. 56.0. This is from the VDR, the DR to the SR. There's the layer 2 stuff there. And then the layer 3 stuff is, again, my web talking to the physical. Do we see the reply back? We've got the reply back just below that. We see, again, we have the outer MAC. Where are they? The outer MACs, which is the Geneve, the source and destination. This is, again, from my edge, 154 to my host 3. That's the tap. So this is all the, the tap stuff here. Okay. We see the V9 now is 10800. 10800. What is that? Let me put that through my converter. So, the V9 10800 is basically 67584. Let me go back to that other edge. Is it going to have it? Let me exit out of here. So I'm back to the edge. Let's type in get logical switches. And you see app web is 67584. Okay, so this is the return path. So it's coming out of the SR, went to the DR, did a route. It's now on web, and that's why we see that VNI over here. Then we see the source MAC 564452. Yeah, that's the DR component. And then we see the MAC address DC6D. That was my web 1's MAC address that I mentioned in the very beginning. And we see, again, there's the source IP is my physical to the destination, which is my web. Okay, so I'm showing you the information on the tap here. Okay, and by the way, the expression, one of the things I noticed, I use my expression, the expression IP, I use the IP of the tap. Because I am on the tap, my interface is the tap, I notice I cannot use the expression to filter stuff that's been encapsulated. I can only filter on the Geneve header, okay, because I'm on the tap. But if I wasn't on the tap, if I was on, let's say, the interface that's connected to the VLAN, then I could absolutely filter on my VM's MAC. Let me show you that right now. Let's kill this. Let's start capture. Interface 1. That was my VLAN back one. That expression ain't going to work. So let's type in 172.16.10.11. That's my web. Come on, don't make a liar out of me. There we go. So this, I'm now looking at the non-encapsulated stuff. Actually, I was showing I didn't type in the direction. I could have probably typed in the direction as well. Direction dual. Hit enter. Okay, I wasn't typing in the direction. Or if I wanted to get a specific one, only the inbound stuff. So this is all non-encapsulated. So what do I see here? I see a source. There's my web going out to the real world, right? And here is the MAC addresses. Again, the MAC address here, the source, and the destination. Okay, and then we see the return path from the source to the destination web at this point. Now, again, I'm capturing at my uplink. So again, it's important that you know which interface is configured, and there's a lot of ways that this can be configured. Okay, so this is one method, folks. I think that kind of covers it. I don't want to make it too long, but hey, if you enjoyed this and you found it beneficial, hit that thumbs up. And if you haven't already subscribed to the channel, it only takes a second. It's free. Hit that subscribe button. I really appreciate it. I'm trying to hit 1,000 subscribers, and I'd like to do it sooner than later, to be honest with you. And without subscribers, there's no content developers. So thanks for sticking around. Leave comments below if there's something you want to see or do or whatever. Again, this was a subscriber request. So, and I try to get them as quickly as I can. I am limited on resources though, but thanks again. You have a great day. Bye now.